Welcome back, arcade enthusiasts. It is time for part number 2 of the Inca Boss slash Blueline. Now, off the bat, I looked at the schematic and I remember that this was that output was held high all the time. I looked at the schematic and that goes into this 08, which is right here. I cut it off the board. And one of the inputs, it's just driving, it's just buffering, right? It's buffering that signal. So one of the inputs is actually held to 5 volts, and the other input is that signal, and the output will just be a buffered version of that signal, right? Well, the two inputs were shorted together. That's why it's being held high. And if I don't think I will be able to do this. It was pins 8 and 9 were the inputs. Ooh, this is going to be tough, isn't it? If I try eight and 9. I'm going to try. There's 8 and 9 right there. And they're shorted together internally. So this guy is no good. And we can prove that. I'll put this back in the board and fire it up, and you'll see that that is no longer held high. So let me do that. Put that in there, fire it up, and then we'll check that out. Okay, put that back in, and now we can probe that signal, and we will see, it's pin 3, that it is no longer held high. And this is what our screen looks like. Still got issues, but that at least, this is that Blueline game, and it kind of looks like it should. It does have that gridded X, remember. We look at what it's supposed to look like. That's what Blueline is supposed to look like right there. And we see it looks like this right now. So yeah. So this is the next one I want to look at because it is missing a chip. So we'll just probably go ahead and replace that 08 that I just cut out of the board. And then, you know what I'm going to do? I'm going to replace that 08, and then I'm going to move to this board. I'll just, yeah, because I want to do them in a line. So I'll replace the 08 and then start working on that one. Okay, 08 replaced. So I'll pop this down in here. And we'll start with the ball PCB. I'm actually going to, the score one, I'm going to do last. No, I'm not. I'm going to stick to my plan. I'm going to do the score one next, and I'm just going to move on down. So that'll be the plan. I'm looking at the waveforms of this 0, 0. And of course, a 0, 0, you need 2 1s to get a 0 on the output. And this one looks a little strange. It looks like that second line is influencing the top line. This looks like it's just a pretty rhythmic pulse. And then when it comes to this one, that's kind of influencing that top line. And I believe that this pulse is way wider than it should be on the bottom. I think it should be as wide as these pulses right here, but it's just influencing that one right there. So regardless, I'm replacing this 0, 0 because I believe there's some just bleed through or whatever between the inputs. That should be a much more narrow pulse. Interesting. I'm looking at another 08, and right away I don't like the way that output looks. But if I pulse the top line, you can see that should just flat out drop low, and it doesn't. It's just not good. Yeah. So this one's no good. 08. Okay, we got two 7490 counters right here, and they're both really corroded. This one has floating outputs. This one doesn't, but I'm going to replace both of them. The outputs on that top one are 12. You can see this is what 5 volts looks like. That top line. This is the first input or output. It's floating. The second is floating. The third is floating, and the last is floating. So yeah, that one's just completely no good. So I'm going to replace both of them. This one, all of the outputs are just low on this one, which they might be because it's not set to count. But yeah, this one's definitely no good. So I'll replace both of them. And another one, we got a 08 with floating outputs. And basically all of the outputs are floating on that one. So, and then I've got to actually get the analyzer out to do the rest of these. I'm just doing what I can with my 4-channel little scope here. So we have a 42 and then a bunch of 53s, 95s, and stuff like that. So we'll have to go through all of that. Yeah, and by the way, this thing's done crapped out again. No, it's just doing this. So it's all good. I imagine that some more stuff on these paddle boards. I just caught myself. I almost said bad word. But probably a bunch of stuff on this board has crapped back out, or crapped out these 2 paddle boards. Maybe even the ball PCB. We'll see. Who knows? Maybe the court board. Maybe something died on it. Ay. Alright, so after going through this board, got quite a few that are marked red. Remember, this one was dead for sure. This one just corroded, so I'm going to replace both of those. Red, 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 red. And these other 95s, I almost want to just remove those. They're shift registers, and they're kind of confusing how they work. I kind of want to just remove those and put them in my tester. And yeah, so there's a lot on this one too. It's just dead. So we'll replace all that. Alright, I got my tester out. I removed those, remember those 4 7495s that I had tested. I marked 3 of them green and 1 of them red, but I wanted to remove them and test them out of circuit in my tester. And as I had them marked, they are. 3 of them are good and the 1 is bad. So, alright. I've got the board reconditioned. New sockets. And we're ready to repopulate this board. I'm going to go ahead and test all of the chips that I'm putting in the board to make sure they're all good. And go from there. Alright, I've gone through this first paddle board, and there are 1, 2, 3 questionable. There's 3 bad and a questionable. And then there's some timers on here. I don't know their condition. And then there's this 7425, which is a 4-input, a dual 4-input NOR gate with a control pin. It's got a strobe pin where it has to be high for it to work. If it's low, if that strobe pin is low, the output will automatically be high. This guy right here, 7425. And what they've done, they're just using this as a straight up 4-input NOR gate. And they left the strobe pins floating so that it would just constantly work as a 4-input NOR gate without the strobe deal. But what they should have done, and what designers did later on, they always pulled unused like reset lines or strobe lines like that. They would always pull them high through a resistor. If I can do this, I don't know if that's on there. Let me put the camera down. Be right back. Okay. If we look at our strobe line, remember, if it's low, if that strobe line is low, then the output will automatically be 1. Doesn't matter what the inputs are. The only time the inputs, the only time the output reacts to the inputs is if that strobe line is high. And what they're going for here is they left the strobe lines floating so that they are high all the time, so that it just acts as a 4-input NOR gate. And if we look at our strobe line, remember this was floating. Now, that's awfully close to not being floating, right? It's being influenced by some line. And I do believe that is still floating. But over time, I don't know if that will continue to go higher and higher. Both of the sides are like that too. Both of the strobe lines. Here's the other one. So they're both like that. So what I'm going to do is I'm going to pull those both high through a 1K resistor on the back of the board and then test that and make sure that it's working properly as just a basic 4-input NOR gate. So yeah, and then we'll relook at those two strobe lines after I pull them high, and yeah, so I'll be back. Alright, so I just added a little 1K resistor to 5 volts and ran a jumper wire to those 2 pins. So those are now pulled high. Now I'm going to go ahead and put it back together, and I have to get my analyzer because this is only a 4-channel scope and I need 5 channels so it's 4 inputs and 1 output. So I'll go ahead now and test that guy. And there we go. Now they're pulled high proper. You can see that top line. It's pulled high. No more chance or opportunity for this thing to interfere with the function of this chip. Here's the other one, pulled high. Alright, so I will get the analyzer out so that I can look at that guy. Just make sure it's working right, and then I got a few chips to replace on this one. Alright, I'm on the 25, and it is a 4-input NOR. And we're not worried about the strobe input at all. So we're just analyzing this as a straight up 4-input NOR gate. So the only time in a NOR that you'll see a 1 is if all of your inputs are 0. If any or of the inputs are a 1, the output will be 0. So really what we want to focus on is an input of 0, because that's the only time that we'll get a 1. And if we look at this, you can see it flashing across. Whenever there's a 1, the input is 0. And we can focus into that better with the trigger and just trigger on 0. And now you see, whenever it's 0, you get the 1. That's how it's supposed to work. And we can switch over to the second side of this. I don't know, that side might not even be used. Just delete all, go to overlay, go B, and then back to sequential. Yeah, we're getting a 1 on 4. Now, let's clear the trigger. Okay. There's 0 and 4. 0 and 4. Now, depending on whether this side is actually used or not, well, this is definitely not working right. We're getting a 1 when it's a 4. And that's definitely not correct. The only time we should see this 1 is at 0. Yeah, see that? Let's go back to the other side. I want to trigger on 4. Yeah, see 4, it works fine on this side. Now, one thing that it might be doing is that other side might not be used and the inputs are all floating so that you're getting erroneous data. That could be happening. I have to look at it and see if it's actually got traces going to that other side. If it's not used, I'm not going to worry about it because it's probably... Here, let's just do this. Let's remove this. Pop this on here, and then let's just look at the inputs. No, look at that. It's being used. Yeah. They're all being used. So this chip is no good. We just found another bad chip. Oops. Let me try to do this again. Pop this back on here. There we go. Okay. Yeah, this side works fine. And one thing I like to do is I do like to trigger on everything. I'll start with 0. Okay, we're trigger on 0. We should have 1. And I like to go up and trigger on everything. Trigger on 1. 1's fine. Trigger on 2. 2's fine. There should not be a 1. I like to trigger all the way up to 15. 4. That's 0. 5. Fine. 6. That's fine. 7. Fine. 8. 8's okay. 9's okay. I can see right there. See, I see 8. I see 9. I don't see A. Nine is fine. Let's go A. A, B. D, F, and I saw C. So this side works. Now let's just stop, delete everything, put the other side on. Repetitive, let's go to the trigger, let's clear the trigger, and then start at 0. 0's fine. Trigger 1. 1's fine, no 1. Trigger 2. 2's okay. Three is okay, but there's 4. So yeah, we know 4's bad. There's 4. Getting a 1. Should not be. So we already know this 25 has to go. This chip needs to go. So all right. Well, the next chip that I put into here, I am going to also pull those 2 pins high because they're not used. So, all right. Very good. All right, progress update. So I put this board back together with all the chips replaced, and now I can put it back in the case, in the set, and I'm to this again. Whereas before it was, hey, and that ball is bouncing on the, it's bouncing now. See that? See it bounce on the edge? So that's some progress right there. So now we'll go through this board, and this one I don't have to mess around with that expansion board. I can get to this one, no problem. We still have to do the ball PCB. And then we might have to go back through and check some of the stuff, do a little redundancy, because we may have had something go bad since. So we might have to go through this thing a couple of times. I don't know. We'll find out. Let's get this one all analyzed out. And then we got the ball PCB. Those will affect, these 2 boards will affect our sync and our video. So, yeah, we need to do those 2 now. You know what I think I'm going to do is call this part 2. Alright guys, so part 2 is in the books. We went through a couple more boards. Paddle 1 and the scoreboard. The scoreboard and the first paddle board, we went through those 2 boards. And we made a little bit of progress. Our screen is back. At least we can see the mesh screen now. I mean, that's progress. So I'll go ahead and upload this as part 2. And next one we'll tackle 2 more boards. On the next part we'll tackle the ball PCB and paddle number 2 PCB. So yeah, and then we'll see where we're at after we get those 2 done. So stay tuned.